Hello and welcome to Organic Chemistry. Today we're looking at two aromatic reactions. The first one is called nitration and the second one is bromination. So for nitration, you need two reagents, nitric acid and sulfuric acid. And when those two are mixed together, you end up generating a nitronium ion intermediate, which is the electrophile. In aromatic reactions, if you start with this, benzene has a hydrogen at that position, and then react that with an electrophile, this reaction is called electrophilic aromatic substitution. You end up substituting the hydrogen with the electrophile. If you're given an aromatic compound like this, and let's say you have a CH3 group there, and you have an NO2 group there, nitrate, and then you react that with nitric acid mixed with sulfuric acid, and we say that that generates nitronium ion in situ, which will then become the electrophile, and eventually you end up substituting a hydrogen with that electrophile. Now the first thing you will need to consider is to determine where the new electrophile will go to. So if you look at this CH3 group, it's an ortho-para substituent. So it will favor the new group adding to either the ortho and at the same time the para position. On the other hand, the nitro group will favor meta addition. So it will favor addition to that position, which is meta. Remember, meta is 1, 3, and also that position, meta. So we see that both of these groups agree that the new group should add to that position and that position. So you end up with a mixture of two products. And now in the first case, you end up adding the nitro group to that position. And in the second case, you add to this position. So you end up with the nitro group at that position. Now in the second reaction, bromination, we need two reagents. We need bromine and a metal catalyst, iron 3 bromide, and that will end up generating a bromonium ion in situ. So again, similar to what we just saw, if you have an aromatic system, now this CH3 group, which is an alkyl group, will favor addition to ortho and to para, 1,4 position. This ortho will not work because that place is hindered. It's between two large groups, so between this group and this group. Now if you look at this carboxylic acid, that's an electron withdrawing group, and that means it favors meta addition, and its meta will be here, but this position is already occupied, so no addition will happen there. Now what you need to know is that electron donating groups are stronger directors than electron withdrawing group. So a CH3 here is an electron donating group, and therefore this position and this position will win, and therefore you end up with these two products. So if you use Br2 with FeBr3, remember that gives you the bromonium ion, and that's what we are adding. And now the bromonium ion adds to that position, so you end up with a Br at that position, and also adds to this other position, so you end up with a Br at that position. And those are the two products that will be formed. Thank you for watching. If you enjoyed this presentation, please like the video and also subscribe.